of our lecture videos. Today I'm considering probability and probability distribution. That has to do with our unit 3. Under probability and its distribution, we mostly look at the occurrence of event occurrences. These occurrences are with respect to some probability. What's the probability that it would rain today? What's the probability that the sun will shine so high? What's the probability that there's going to occur? So event happens with probability. Sometimes we are so certain about it, other times we are not so sure. So what is the certainty here? This means that when the event or probability of the event is equal to 1, we are very sure of the event occurring. If it's equal to 0, then we know that it is not going to occur. So what happens in between here? If it's 0.5, someone will say, we are 50% sure that it would happen or not to happen. So this is having probability of it not happening and then it happening. What if it's 0.2? What is your case here? If it's 0.9, what do you say? So some of us have these weather forecast apps. I have one where I used to check what happens in the day. Is it going to rain or not? And when I say probability of, let's say, 0.4%, I would say there's not going to rain. The probability is very small. But when I see, let's say, 70%, then I know it's likely to rain by hook or crook. So this is the application of probability. It gives us some level of certainty and assurance of occurrences of some event. Then what about the distribution? We come across distribution in the case, let's say we are performing an experiment. Experiment can be anything, a process to have some outcome. We have a pool of possible outcomes of our experiment. And out of these possible outcomes, we can have the event. It means the outcomes that actually happen. That is the event with some probability measure on it. In most cases, I can't perform the experiment several times to know all the events that will happen. So I perform one experiment, I have event 1. I perform the second experiment, event 5. I perform the third experiment, event 7. That will be so much work to do. And so if I'm able to have some sample of the event, I can describe a distribution for this sample. And there are so many distributions. So if I know the distribution argument, I can generate the other data. That is what we are trying to say. We can have an event following a normal distribution. You need the mean and then the variance of your sample. It can follow a binomial distribution. You need the number of success trials, the number of trials, and then the number of success, probability of the success trials. It can follow uniform distribution. You've come across all these. It can follow a Poisson distribution, that is the count. We need just the mean. What other distributions? We have the gamma distribution, etc., etc. There are so many distributions. All these distributions have their own phenomenon they come with, or the process we come with. In a case where we are considering, let's say, binomial, the word binomial means 2. It's just 2 possible outcomes. Then out of it, I can generate my event. So the 2 can be yes or no, a male or a female, just 2 possible outcomes. What else? Male or female, he or she, a head or a tail is a possible outcome of, let's say, throwing a coin. A die cannot be binomial. Like you are throwing a dice, you can have one, it can land in two, it can land in three. That is more than two outcomes. So any experiment that comes with just two outcomes, it follows a binomial distribution. So in that case, so all this follows the binomial distribution. In that case, you need to know the number of trials. How many times are you performing the experiment? You need to know the success story. So let me just use this as n. How many were positive, or how many successful events do you have? So number of success, I'm going to use, let's say, n. Oh, the same n here, sorry. If I use n, I can use, let's say, number of success, r. Then we also need the probability of the success. So probability of r, that is small p. If it's going to happen, there's a possibility of it also not coming, and that is the probability of it not. So not, I use exclamation mark, not r. That is q. Q is giving us 1 minus py. Probability can't exceed 1. So if I know the probability of a success, then not successful becomes 1 minus the success story. And this is all I need. So assuming the same preamble of the movie producer, he goes around to perform an experiment. He goes to his community and asks, would you recommend my movie? You know, the possible answer is yes or no. It can be a positive response or a negative response. Then out of this, he can say he sampled 50 people, which means he approached 50 people. We can ask ourselves so many questions. What's the probability that exactly 2 people said yes, they will recommend? 2 yes. So probability of, if my event is A is equal to 2. It means that I can find what's the probability of 2, at least 2. At least 2 said yes. At least means 2 or more. So the probability of the event greater than or equal to 2. Probability of at most 2 said yes, they will recommend the movie. That's probability of A. That's mathematics and English as well. At most means I can't go beyond 2. So A is strictly less or equal to 2 at most. The other things, let's take this just as 3 for now. So many questions you can ask with the probability. How do I solve this? Now binomial theorem, binomial distribution is giving us the combination of your success and then your non-success n minus r. So realize that P takes the success r, Q takes the rest of the experiment. We're not going to use hand in doing this. If I want to use the Excel, the syntax is binomial. I think this. When you start typing, it would show whatever you need. I think you need the X, you need the trials, you need the probability, and then the count. There's one interesting thing here. If I want to solve exactly 2, you know that it is just exactly 2. It is just P equal to A, 2. But when I come here, I have other ways to solve this one. It means I have P of A equal to 0. Okay, 2 or more. So equal to 2 plus probability of A equal to 3 plus the probability of A equal to 4. 1, 2, 3. Probability of A equal to 50 because I did a 50 sample. That would be so much work to do. It means you must find each of the values here and then sum them. That is 2 to 50. But don't forget, probability can't exceed 1. So it means I can write probability of less, at least 2, to be 1 minus probability of when it is greater than, when it's less than 2. So probability of an event greater than or equal to 2, instead of going through this approach of finding greater than 2, so 2, 3, 4, 5, 6, 7, 8, 9, 10, sorry, I can have the probability of 1 because it can't exceed, minus probability of a less than 2. So this one just becomes 1 minus probability of a equals 0 plus probability of a equals 1 plus probability of a, okay, less than 2. That is all. Oh, this should give you the same answer as whatever you do here. So the choice is yours. Now, how do we answer at most 2? At most 2 means that 2 just less or equal to 2. That gives me simply P of A equal to 0, P of A equal to 1, P of A equal to 2. You are done. It can't go beyond 2. In a case where it is a greater number, then you can use a 1 minus the probability of the other, or let's the reverse. Let's go straight to our Excel sheet and see what we can do. Right. So I have already unit 3 probability distribution here. I hope my Excel is cool to look at. What will the probability of A equal to 0? A equal to 0 means that nobody said anything, nobody said yes or no. So equal to binom. When you start typing, you'll get to see the syntax. The first argument is x. It says x is the success of the series of trials. The number of success. The number of success here is 0. Nobody said anything. The total number of trials, we considered 5 people. Probability. Let's say the probability of 0.5% or 50%. So that's 0.05, yeah. And then the cumulative. How do you want to cumulate it? Is it individual probability or the cumulative probability? This is the individual probability. We are dealing at one category after the other. So I'll choose the C equals 0. I enter. This is my answer. Probability that one person said yes becomes binom of, so we have how many success? 1. The full number of tries 5. Probability of 0.05 and then 0. I can't drag. When you drag, it would give you error. This is not correct. It is repeating. So it is using the same value, which is not so. So just take your time and just compute them. So the number of tries here is 2, 5, 0.05 and then 0. What someone can also do, if you want to do the dragging, it means I have a table. This is the success. So success is 0, 1, 2, 3, 4, 5. Then I can have my probability, this is my P, as 0.05. Then I can have my N, the entire trial. It was 5. Then I can have it this way. So it means that my probability of 0 becomes binom of x, which is 0, comma, so I pick the cells. The number of trials is 5, comma, the probability is 0.05, and then my cumulative is 0. So let me just extend this entire cell. So let me have a table for this, or let me just let me just use a different color for. Okay, now you realize that I can now drag this one, and what happens? I get error. That's because see what it's using here. It doesn't know. It is picking n cell here which has no value. It's picking another cell which has no value. So what you do is that you know some of the values must be fixed, like your probability must be fixed. So I have to fix my probability. My number of trials is also fixed, so I need to fix my cell 0, but my success story is not fixed, so I get the same answer. Now this is correct because I fixed certain parameters. I'm fixing this guy, I'm fixing the trials here because they don't change. If you don't fix them, it means that they are going to take the other cells which are empty. So I've turned 2 ways to do this. So let's see if you get the same answers. So equal to binom. Some of us want to go through this approach. X is 3, trial 5, probability 0.05, and then 0. We're getting the same answer, right? Yeah. So binomial, number of trials is, success is 4, trial is 5, 0.05 for probability, and then cumulative of individual. Then the last one, probability of having all 5 saying yes. I will recommend your movie. So success is 5, the number of trials is 5, probability is 0.05, cumulative of individual. We have the same answers. Interesting. So which way do you want to go? Would you go by the table form? Let me highlight this in a table. It's not really necessary, but at least to clarify whatever I'm doing. Or you go by the individual joint. So let's answer our questions here. At least 2 said yes, I recommend the movie. At least means 2 or more. So now it's going to be the sum of 2 or more, means right from this 2 to the 5. So L5 to L8, you must pick the cells correctly. So that is it. If I want to go by the other way, at least 2, it means 1 minus 1 less than 2. So I have 1 equal to 1 minus the sum of less than 2, it means 0 to 1. I should get the same answer above. And that is it. So that is what I explained here. Is either you go through this approach, you find all the possible not greater than 2, or 1 minus the less than 2. You get the same answer. Okay. Now probability of at most. At most means from 0 to 2. You can't go beyond 2. So I pick the first 3, and that's the probability. Exactly 2 people said I would give you a thumbs up for your movie production. Equal to 2, I choose just this number. So this will be equal to just a cell, because it's exactly equal to 2. You realize that none of the numbers here is greater than 1, and that should tell you are correctly doing your probability distributions. If you have values greater than 1, you are in trouble, or less than 0, you are in trouble. You must check your binomial distribution as well. Right. So this is the end of unit 3 on probability and probability distribution. So far we've gone through the descriptive, we've done the correlation, we've done the regression, and then we did the probability. 3 more units to go, and then I hope you take your time and understand whatever I've talked about here. Good one.